Thanks, Ken. Good. Thanks, Ken, and I just want to thank you for both warm welcome reception. Ken asked me to come here literally about a year ago, and due to schedule conflicts and a number of other things, it's been hard finding the time to put all this together, but I'm really glad this has finally happened, and I'm glad to be here with all of you. I get a chance to talk about renewable energy now. Gosh, I feel like I'm on the lecture circuit almost every week. And I start almost every talk with, it's a great time to be in the renewable energy business. It hasn't always been that way. I've been in this particular topical area pretty much my entire professional career. That's well over 30 years these days. I left Bell Labs when I was a young engineer to start the solar programs down at Sandia National Laboratories in Albuquerque, New Mexico, before SERI and now NREL ever existed, before DOE existed. It was back in the ERDA era. And so it's really quite refreshing to see how much things have changed, how, in fact, all that work that's been going on for literally 3 decades is finally coming to fruition. And I'll start with kind of the good news story, because I think the other part that I would like for you to take away this evening is that the challenge that we have in front of us in terms of our energy challenges for the country and, for that matter, for the world are horrendous. They're daunting. They're incredibly acute, and I don't think the national dialogue really fully appreciates that. I think it's refreshing that we're having a national dialogue. I'm pleased that both campaigns in the presidential election are talking about renewable energy in particular, but clean energy and a new energy economy of the future. So I'm going to kind of run through my slides very, very quickly, hopefully to get some stimulation of maybe some questions that are really on your mind. I'm anxious to hear kind of how you view this topic, and I get a lot from your questions whenever I get a chance to talk to you about these things. So I'm going to go rather quickly. I'm going to say some things that many of you already know, and for hopefully some new things that will come, be insights that will be of value to you as well. Our challenges are enormous. I said that earlier. Is it about security? Is it about economic productivity? Or is it about environment? Well, the fact is it's about all three, and we need to do those quite aggressively. There's mounting evidence. We all understand how our climate is changing in many respects. I think International Panel on Climate Change would suggest that is human-induced, and there's lots of issues that relate to the effect that global warming is having. Probably the thing that gets to most of Americans is the price of gasoline. When you go to the pump and you all of a sudden see the price going through the roof, it really it starts to hit home. And this is really where the dialogue has begun. In recent years, it's really about technology, rather about energy security than it is about anything else. And so let's examine that for a moment, and then I'll come back to what renewable energy is and the value and the role of R&D that goes along with that. This is the Energy Information Administration. It's the agency that's embedded within the Department of Energy that gives us projections about where our energy mix is today and where we will be decades from now. This is our mix today. You can see it's primarily fossil fuel, and it will remain that way for some time. Interesting enough, people will kind of be surprised by the fact that we've got 6% renewables today, and the projections are, even though the amount of energy required for the country is going to increase by 34%, that we only get to 10%. And I can tell you that 2 years ago, this same projection was that number would be 7%. So the good news is that they're at least acknowledging that renewables will be more than it is, more than it will be more than we thought it would be last year. But I will offer that it's still quite a bit less than what I think it will actually be. Now, if you just look at the electricity part and you ask where do we get our power generation from, this is the map that gives you that. So it's primarily half coal, natural gas, nuclear is about 20%. Hydropower is about 7%, so all the total renewables is about 9.5%. This non-hydro renewables is 2.4%, and of the 2.4%, most of that, believe it or not, is biomass. People wouldn't expect that, but it's biomass power. Pulp and paper kinds of industries that use a lot of it. And here's wind. Wind is 27%. I'll talk more about that later. Geothermal is 15%. Solar is 1/2 of 1%, and that is of the 1/2 of 1% of this piece, which is only 2.4%, which is a little bitty minuscule piece. And I just wanted to reiterate that. Well, so I've been in this business a long time. As I mentioned, in the first question that I always get asked, and I got a chance to testify in front of Congress last year 5 different times, I got the same questions both times. First question was, when is this stuff going to be real? And the second question is, and how much can we actually get? So the first question I will answer here in a moment. You know, I told the members of Congress, it's real today. It's just not real in the U.S. It's real to the tune of $150 billion a year in terms of an industry, but it's not much in the U.S. And how much can we get is really answered by this particular graphic. This graphic is a projection. Again, EIA is the Energy Information Agency. IEA is the International Energy Agency. This is out of Paris. And then the Pew is the Pew Foundation. All of these various groups that project what the potential can be really have a bunch of assumptions embedded in what they assume. And what was interesting to me is that our policymakers look at these graphics and they say, well, gosh, if we're down here on this one, it's only 5% by the year 2040. You know, the conclusion one draws is why bother? You know, some of these others are a little bit more. What are the assumptions that are behind this? Well, they're over here in the legend, and the legend is that even under the most extreme conditions, we think that the price of a barrel of oil may get to $100 a barrel. So obviously, there's a problem with the assumptions, and it's very clear that what we don't know is we really have a hard time projecting where things are going to be. And I think what you'll find is that many of these folks, these are done by economists. They're done by econometric models, we call them, and they're a little bit like driving your car and projecting where you're going by looking in the rearview mirror. It's what has happened in the past, and if you just extrapolate what has happened in the past to the future, that's the projection you're going to get. That's kind of the way the models are geared, and that's essentially what you get. But it does not accommodate fully the market dislocations that occur when there are disruptions in oil and those kinds of things. It does not take into account, obviously, the volatility of the price of oil and innovation in the R&D community. So that is where I think there is great opportunity, and it really then helps me answer the question that I get from the Congress, which is how much can we aspire to in terms of renewable energy and energy efficiency? And I take that question and I turn it around and I ask it back to the member of Congress, and I say, how much would you like? Because it is not a matter of technical potential. It is a matter of investment and commitment to make these outcomes that you want to have happen. The good news is I had a chance to host the president a couple of years ago back at the laboratory, and he came and we had a nice discussion around a variety of topics. But what was interesting to me was that there was no lack of will for suggesting that there can be a large fraction of our energy mix in the future from renewable energy. And it is a matter of investment and technical will. So in the national program today, here is what you see in terms of our aspirations. And I'll call these aspirational goals, not because we can't get there, but because it takes a lot of things in order for us to get there. And I'll mention that here in a minute. A couple of months ago, we unveiled a thing called the 20% electricity vision. This is a report that we co-authored at the National Renewable Energy Laboratory with the Department of Energy and 50 other groups. And essentially we developed the roadmap by which you get to 20% of our electricity from wind technology by the year 2030. Now this just happens to be the report that if you're watching any of the news programs these days, you'll see T. Boone Pickens up talking about renewable energy and talking about wind. He holds this report up and says, now he wants to do this in 10 years, which I find really aggressive. But T. Boone has a lot of experience in the marketplace. I mean, I certainly do value how he approaches things. I will also add that there's a 10% electricity goal by the year 2025. but from solar, and there's also a renewable fuels. In this case, it happens to be biofuels and ethanol in particular, 36 billion gallons by the year 2022. That's all part of the Energy Security Act. Now, what I tell the members of Congress, and I had literally 20 members of Congress come through the laboratory last week, was the following. If we were to achieve each one of these goals, it would cost us literally, down here, $2 trillion of investment over the course of the next 2 decades. Now, the interesting thing is that if you look at what EIA projects that there will be, in fact, $2 trillion investment in infrastructure in this country for energy over the next 2 decades. Internationally, it'll be $22 trillion. It is a lot of money. A lot of money will be spent in our energy infrastructure over the course of the next 2 decades. The question is, what will we spend that money on? Will we spend it on the conventional approach to our energy mix, or will we do something different than what we've done in the past? And that really is a policy question, and one that I think deserves a lot of dialogue and discussion in the marketplace. But the news is here, the government's not going to do this. The private sector is going to do this. And the government can facilitate and help steer the investments, but that really is what needs to happen. When we talk about how you get to significance, we talk about speed and scale. We need to move technologies into the marketplace much more quickly than ever before. I mentioned I'd started in this business 30 years ago. 30 years ago, I was in the laboratory. We were doing some very cool science and very cool research. The technologies that were in the laboratory then are the technologies that are commercial today. It took 30 years to get them from the laboratory to the marketplace. And I told the president when he was out, I said, you know, Mr. President, it's our job to make sure it doesn't take 30 years to get the technology that we have today, which, by the way, is phenomenal technology. We have no lack of innovation and creativity in the laboratory. But we cannot wait 30 years to get that technology into the marketplace. We've got to compress that. It really is about speed and scale. If you can't move that technology into the marketplace and invest the $2 trillion that we're going to invest in these technologies, then we're going to lock in some technology that we're not quite as comfortable with going forward as we are with some of these newer advanced technologies. So, renewable energy, and this is electricity. This is about replacing fossil fuels in terms of our transportation sector, and this is about efficiency. There are certainly cost and performance issues with some of these technologies, albeit they're not as acute as some people believe they are. But more importantly, we have infrastructure problems with these various technologies. It's not really about the fact that the technology can't perform. It's that the technology really is not a good match for the market conditions that we have today. Now, I'll just go through a couple of other things real quickly. What we're seeing today is this is our renewable energy nameplate capacity that's being added on an annual basis to the country. And what you'll see is that now we're up around 30 gigawatts, and that's a significant amount of energy, believe me. Most of that, the new stuff is wind. I'll talk a little bit about the wind technology here in a moment. I mentioned that the investor community is making an investment. It's a $150 billion industry today. This is how much is being spent by the venture groups, and this is the growth rate over the last couple of years, year-over-year annual growth rates. These are phenomenal growth rates, starting from small numbers, but going very fast. This is what's different about this cycle in our energy mix. This is the first time that we've seen this kind of private sector investment. And you talk to the investors and they'll tell you the reason that they're investing in these technologies in the clean tech sector is because they believe there will be public policy. And ironically, they are now influencing public policy because it's their dollars that are now in the marketplace. And so there's a lot of things that are going on. I mentioned a lot of stuff going on in the laboratory, and I've got to tell you, as a scientist and researcher, I am absolutely astounded and impressed by how much creativity there is in the marketplace, in the laboratory right now, and moving into the marketplace relatively quickly. What's different about today is if we're going to affect the marketplace, we really have to do this in managing that lab-to-market interface, and it really has to do with partnerships. It has to do with harnessing the innovation that's in our universities, that's in our research labs, that's in our public-private partnerships, and moving those into the marketplace much more quickly. And to take essentially government and both federal level and state level regional economic development as the drivers to move the technology much more rapidly going forward. Now here's my one commercial for the National Renewable Energy Laboratory. Again, we are a Department of Energy national lab focused on moving technology into the marketplace that's renewable and that has to do with energy efficiency. And as we look at the context that we are working in, our job is to get technology in the marketplace. So it's not about doing the widgets on the supply side or even looking at the end use side. It's looking at market solutions that marry both the supply side, the end use side, and then everything in between that connects the supply to the end use. And it has more to do with distributed technologies moving into the marketplace much differently than we've seen in the past. Our energy system today was built on the concept of big power plants and big wires. And today we have the opportunity with renewable resources that are very distributed. We used to think that was a liability. It actually is an asset. Is to harness that at the local end use, so you don't have to do so much transmission and delivery. That in fact you can do a lot more with that going forward. I'll mention efficiency because efficiency is the low-hanging fruit. This is the one message that we preach over and over to the Congress, and that is there are a lot of things that we can do today that make great business sense to do, and we just don't do them. There was a couple of studies. This one's done by Vattenfall. It's a company out of Europe. But there was a similar study that was a follow-on to this done by the McKinsey folks, doing essentially the same thing. They were looking at what would so assuming that you care that you emit carbon into the atmosphere, and assuming that you put a price on that emission, what would be the price of carbon necessary in order to make these technologies viable in the marketplace? I mean, that would be the question you would ask. Well, what you find is that this is zero here. These are all negative numbers, meaning that it doesn't take there to be any price on carbon. In fact, carbon can be a negative number, and these still make sense to do in the marketplace. And if you look at them, what they are is they're efficiency things. They're insulation. They're fuel-efficient commercial vehicles. They're lighting. They're air conditioning, water heating. A variety of things. Here's sugarcane biofuels. There are a number of technologies that make good business sense today. In other words, you can get a return on investment by employing them, and in fact, we just don't do it. And you ask the question, why don't we do that? Let me give you an example. Buildings matter. So first of all, here's our end-use sector. Buildings use about 40% of our energy. Transportation uses about 28%, and industrial processes use 32%, about 100 quads. This is a couple of years ago. Buildings, both residential and commercial, have these loads, just for reference, the things that consume energy in our buildings. 72% of the nation's electricity is spent in our buildings. 72% of electricity is spent in our buildings. Really inefficient use of electricity in this case. 55% of our natural gas is spent in buildings. Now, again, these are just some of the goals that we have on the buildings thing. I'm going to mention here now this notion about how can we do better on efficiency and why don't we do better on efficiency. Well, the reason we don't do better on efficiency is that buildings are built by builders and the construction industry who make decisions to build the building based on lowest first cost. They don't really take into account what the energy consumption of that building will be for the future. The tenant is stuck with the utility bills for that building for the life of the building. So if you were to look, and pardon me for showing a graphic here in a public meeting, but what you have here on this axis is the cost of a mortgage and the cost of your utility bills. And if you just built a building to code and say this particular house, this is a 2,000 square foot, two-story home with certain conditions to it. The price of your mortgage and utilities on dollars per year over the life of that building is shown right here. What it shows is that if you were to put in efficiency measures in that building, and in this case it's less than 10% of the initial price of the home, to put in efficiency measures, you could actually, over the life cycle cost of that home, show that you can save up to 50% of the energy that that home will actually consume over its lifetime and still make it cost effective to the tenant over the lifetime of the building. In other words, you could put the energy efficiency measures in that home and save a significant amount of money, as well as 50% of the energy that that building will use over its lifetime by just making those efficiency investments early on. And we don't do that because the builders build the lowest cost, and the tenants are stuck with the bills. They're stuck with the utility bills. Now, the solution to this is very simple. We like to say there's a hard way and an easy way. The easy way would be to change the building codes. If you were to just change the building codes to require that the building actually be green or greener when you build it, then you're in a position where you can actually maximize or optimize the value of that home. We don't do that because there's lots of jurisdictions and a variety of complications in getting to energy efficient buildings. What's interesting to me is that we're building a building at our laboratory right now that our criteria for that building is that it will consume no more than 25,000 BTU per square foot. Now that's a figure of merit. All of the national laboratories in the Department of Energy, on average, have 250,000 BTU per square foot footprints. We can build a building at 10% the energy consumption today of what our average stock is in the entire national laboratory system. That is amazing to me. And this building we will build, by the way, is a 220,000 square foot building. It'll hold 800 people, and when we're done with it, and we're going to put photovoltaics on the roof, it will actually generate as much energy in the course of a year as it consumes. It'll be a net zero energy building. It can be done. It's not a question of can it be done. It can be done. It makes good sense. We don't do it because we have structural issues. Those are what I call market failures. Those are the things in the marketplace that need to be fixed if we're ever going to get to the outcome that we want. I'll just say a word about vehicles, because vehicles really is the other big consumer of energy that we can fix. There's no reason we should not have much more efficient fleets than we have today, other than over the course of time, we as consumers have valued things like bigger cars, higher performance, safety, a variety of other things that consumed our energy on these vehicles more so than the value that we put on saving fossil fuels. So that's changing. That's changing, and we need to make that stuff happen more quickly than we've had in the past. There's lots of issues with plug-in hybrids. I got to tell you, these are technologies that are just now coming into the marketplace. I think we should have gotten started 30 years ago. It'll still take a while to get there. The big thing, of course, is batteries. Where's batteries on here? Batteries is really the biggest problem that we have. And we talk about plug-in hybrids because regular hybrids, and I drive a hybrid car. A hybrid car allows you to get about 10 to 30% savings on your fuel economy. However, if you have a plug-in hybrid and you run on the battery most of the time, you can actually, if you call it, fill up your car with electricity. And the amount of fossil fuel you can displace is between 30 and 70%. That's really the kind of technology that you want to go to. And by the way, that fuel switching to electricity plugging in your car, you're plugging in your car typically at night when there's not a big load. Plus, the cost of electricity for driving your car is roughly between a half and 1/10 of the cost of what it would cost you to run on a gallon of gasoline. I have plug-in hybrids at our laboratory that we essentially we charge with solar. We charge them with solar panels, and the cost that it costs me to drive those cars is 1/2 of what it would cost if I was filling them up with $3 a gallon gasoline. So even with solar, that's very expensive, I can do that at half the cost that I can do it with regular fossil fuels. So this is the technology we want to go to. It is about the batteries, and we've got to get there sooner or later. Lots of technology in terms of materials, roofs, lighting, and superconducting. If there's one message I give to the politicians is that we are under-investing in the R&D that will allow us to change the game in which and how we do our energy economy. There's a lot of technology that can be applied to moving us in another direction than we have in the past. Let me just mention a couple of things about supply, because this is kind of what people think about when they think about our laboratory, is the supply part, not the end-use part. But I always get the question, how, we've spent all this money on renewable energy. It turns out that over the last 30 years, we've spent less on renewable energy than we have on nuclear. We've spent less on renewable energy than we have on fossil. But nevertheless, what I tell the politicians is, this is what you've gotten for the investment that you've made, something like $7 billion over the course of 30 years. You've gotten these reductions in costs, life cycle costs of these various technologies, in some cases, factor of 10. So there's a lot of technology moving quickly. Wind, you keep hearing about wind. Wind is the fastest growing technology in our infrastructure today. 35% of all new capacity additions in the electricity sector last year was wind. 35%. 20,000 megawatts, that's 20 gigawatts of energy capacity. That turns out to be, on an as produced basis, it's 1.5% of our electricity generation. That's, after you account for the wind doesn't blow all the time and all that kind of stuff. There's a lot of potential here. These machines are enormous. They're huge. There's issues regarding view sheds, and these don't look so pretty in some cases. It's interesting talking to some of the congressional folks down in Texas. They say, they may not like them in Massachusetts, but we like them just fine down here in Texas. So I think it's they've gotten used to looking at their oil derricks and those kinds of things. So these aren't quite as much of a problem visually. This is where you see wind being installed in the country. It's installed primarily in the windy places, but there's lots of places where it's not being installed. And it could be, and that really has to do with public policy. It's got to do with what's driving the technology. I'll show a map later here about the various states and what the various states are doing. It's being driven by state regional policies and a little bit by federal policies, but not much of that. I show a couple of graphics here because I get a lot of tables rather. I get a lot of questions from utilities, and they say, well, if I put too much wind on my power grid, it's going to cost me extra money. Well, we've done a bunch of studies, and the studies and this is just to show you that we've done the studies. If you wanted to include 30%, and Dick Kelly, who's the CEO of Xcel Energy up in Minnesota, is on my board, and I have the kind of on pretty good authority. What they'll all tell you is that you will spend about 0.5 cents a kilowatt hour. Okay, 0.5 cents a kilowatt hour. On average, you pay somewhere between 9 and 12 cents a kilowatt hour on your electric bill. 0.5 cents a kilowatt hour to put 30% wind on your grid. Additionally, they say, well, you have to put a bunch of spinning reserves. You got to put a lot more reserves if you put wind on there, because the more wind you put on there, the more natural gas I have to have in order to make sure that I'm covering the load whenever the wind's not blowing. Well, we've done those studies, and those studies also give you the same kind of numbers. You have 5% reserve margin on a 23 gigawatt grid in the Midwest, and if you want to put 25% wind on your grid, you'll need 7%. It's roughly 400 megawatts out of 23,000 megawatts. It can be done. It can be done at a very reasonable price. I'll mention marine energy. Marine energy is kind of a craze now. It's kind of getting resurgence, I guess, of wind, of ocean rather. And what we find is that it's really embryonic. I'll just be honest and say we've got 35 to 80 projects in the entire world that are going on right now. A lot of potential there. A lot of potential there. This is the amount of energy in wave ocean wave rather, ocean current, a river current, tidal. There's a lot of energy there, but we are just at the beginning stages of doing what I would call any kind of serious R&D programs on ocean technology these days. This thing has laid dormant really for 25, 30 years. We have not done hardly anything. Lovely Europeans are doing some things on this. I'll mention solar because this is the sunshine state, I think, right? I'm very bullish on solar. Solar is probably the farthest back in terms of its maturity, but the technology that's got the greatest potential. We're now just now getting to the point where we have about 1 gigawatt of solar on the electric grid in this country. That's that first graphic showed. This is a minuscule amount of solar. However, solar technology is certainly the photovoltaic, the direct conversion of sunlight to electricity, is probably one of the most elegant technologies that we have. Comes out of semiconductor technology, as many of you know. Concentrating solar power is more of the conventional, make hot water or steam or something and run a steam turbine with it. That's technology's coming along as well. Lots of technology opportunities. But where conditions exist, there is, in fact, really nice market niches for these technologies. Certainly standalone power when you don't have access to a grid, all these kinds of things. I'm putting some fairly significant amount of photovoltaics on my home in Colorado, primarily because it's driven by public policy. In Colorado, we have the thing called a Renewable Portfolio Standard. It was voted in by the voters. It's the only state in the union where we did that. And in fact, the utility pays for half of my solar installation. And I will actually pay back the amount of money that I have out of pocket in 3 to 5 years, and then my electricity bills will be constant from that point on. Now, that's a pretty good deal for us in Colorado. If you have to pay the full price of the system, it's not such a good deal. But eventually the prices will come down. The technology is getting better. The efficiencies are going up. It's slowly in some cases. But the technology that's in the marketplace today is the most efficient technology, is roughly around 20%. In the laboratory, we're demonstrating small devices now that are 40%. So I can remember when 20% was the world record. That was literally 30 years ago. Now that's commercial product. And so there'll come a time, hopefully not 30 years from now, but something sooner, where 40% will be the stuff you see in the marketplace. We started with these little systems that, on your rooftop, and then they got a little bit bigger, and then they became fields, and then they became bigger fields. They put a big system in Europe that was like 6 megawatts, and then just earlier this year we put 8.2 megawatts in Alamosa, and I think FPL has announced that they're going to put 25 megawatts, 3 times this particular size unit here in Florida, sometime in the next year or so. So this technology is moving in terms of power parks. It's also moving in terms of our technology for residential. Geothermal, there's a lot of opportunity here. We can take advantage of what we know about enhanced geothermal drilling from the oil and gas industry. We haven't done nearly enough as what we could do, and there's great opportunity there. I'll say a word about biofuels because it tends to be the hot topic. I get the chance to brief the Secretary of Energy pretty regularly these days. He promised the President we were going to get this renewable fuel standard goal. And by the way, we've always talked about getting to the fuels targets that we're looking for, 36 billion gallons in the case of the new legislation, from non-corn ethanol. In other words, from non-food related biofuels. That really is where the great opportunity is. We've given rise to this. I mean, people ask, what's the cost of these things? The cost today is roughly right in here, $2.50. We're probably closer to $2 these days. This is the various components of that cost. Our goal is right here, the 20 and 12 target. I'm quite confident we will reach that 20 and 12 target. And this, by the way, is about $1.30 a gallon of ethanol. It's equivalent, because there's not as much energy in a gallon of ethanol as there is in a gallon of gas. It's equivalent to $2 a gallon of gasoline. Okay? So by 2012, I am quite confident we will have commercially ready technology at $2 a gallon, not using corn, using the waste products of corn stover, or for that matter, wheat straw, or a variety of other technologies, including woody products and forests and those kinds of things. This next little graphic is more of a little simulation that we have crafted through our high-performance computing, but to demonstrate the complexity in a corn stalk. This is what we call corn stover. It's what's left over in the field after you harvest the corn, and nature has engineered this essentially biomass. It's a collection of carbon and hydrogen, oxygen atoms in a way in which it is resistant to drought. It's resistant to insects. It allows it to be hardy and to hold up the corn product and fruit. It is a very complex set of molecules and structures. And what we've determined by going in there is that the biomass cellulose, which is why you call it cellulosic ethanol, the cellulose is in the walls of the plant. And this gives you a little bit of this fly-through, gives you an impression of how complicated this is. And as you get down in here, now we're going down into the small molecules and nano structure sort of levels. What you have is these microfibrils that are bundles of these long polymer chains, and that's where the molecules are that we're trying to get to. So we do an acid pretreat, and then we take these enzymes that occur naturally, and they go in and they disassemble these atoms and turn them into sugars. And once they've turned into sugars, then we can ferment them just like you ferment the corn fruit itself, or sugarcane for that matter. And then at that point, you create the opportunity to make alcohol fuels. And for that matter, any kind of fuels that go along with that. Tremendous amount of insight going into this, coming from the pharmaceutical industry, believe it or not the energy industry. We have not invested in these technologies at all for energy uses. We have invested in food products and a variety of other things for other applications, but not for these. Ultimately, so it's not really about what this graphic says. It's not just about ethanol. Ethanol happens to be the nearest term thing, but down here is really what we're about, is to take those carbohydrates, which are those long polymer chains that are embedded in everything organic that grows, that we can harvest, and convert those molecules into hydrocarbons like what we need to fuel our automobiles and our trucks. And that is, in fact, not that far away. We're able to do this kind of with alcohols right now, but we'll eventually be able to do it with the hydrocarbons that look like the gasoline and products that we use today. And that will make it, of course, then we don't have to change all the infrastructure and all the things that go with that. So it is really about the technology. I'll say a word just about renewable at scale. You really want to do things where you're integrating these renewable distributed resources in with the other products that are going on. I mentioned earlier, it's not just about the technologies. The marketplace will speak. We're going to spend literally trillions of dollars in our marketplace. This piece over here is really important, and it's the policy piece. The policy piece, we need to get that right as we talk about this with all the various politicians and whatnot. It's a blend of all these three things that will allow us to move more quickly to an end state that we're all about. We haven't had what I would call really strong leadership at the federal level for energy policy. We've had lots of bits and pieces, but we really haven't had it much at the federal level. I show this graphic because this is really where the action is. I've hosted a number of people from the EU and other parts of the world. They come to the U.S. and they hear kind of what's going on in Washington, and they really don't have a full appreciation of what's going out where the rubber meets the road out in the so-called provinces or in the states. There's a lot of activity. The activity that's driven right now is all bottoms up. It's driven by local economic development in primarily the states that are colored here. This is where there's tremendous activity. These are all the standards for all these 29, 30 states that are out there. And they're not just doing renewable stuff, they're also doing efficiency things. This is the efficiency standards that many of these states have. And they are finding that if they move quickly, they can create economic development regionally and locally. In Colorado right now, we've just attracted something on the order of 4,000 or 5,000 jobs based on green technology, based primarily on blade manufacturers and wind technology and solar companies. There is, in fact, a lot of activity. You need three things to really generate local economic development using clean tech. One is you need resources. Typically, many states have resources, all kinds. Second, you need a business climate that's receptive and actually encourages the kind of investment. And third, you need knowledge workers. You need workers, essentially universities and others, skilled base on which you can build these platforms. So a lot of things that are going on, a lot of activity I think is important for us to launch into. How can you do policy responsibly, you need to think about what your outcomes are and how you're going to get there. So I'll end there. Thank you for your attention. I hope I've given you a little bit of a thought process on what we're about, and hopefully you'll have some questions. Okay, I think I'll take some questions, and if you've got some, I'll answer them.
You have avoided any discussion of nuclear power. Would you cover that, please?
Yeah, I would. The Department of Energy has 3 national laboratories that work on applied energy. The Idaho National Laboratory is the laboratory whose role and mission it is to look at what I would call sustainable nuclear power technology. I worked for the University of Chicago for about a year. I got very familiar with that. There is, in fact, I think, an opportunity for nuclear to have a major contribution into our future energy mix. Got to solve 2 problems. First problem is they've got to close the nuclear fuel cycle. We have essentially a non-sustainable industry today that is generating more waste than we can possibly deal with on some sort of rational basis. So we need to close the fuel cycle. The Department of Energy is working on those technologies to get there. Second thing they have to do, if you close the nuclear fuel cycle, it typically means fast reactors. It typically means breeder reactors or reactors where you're generating fuel that can also be of concern in proliferation of weapons of mass destruction or nuclear materials that you don't want to fall into wrong people's hands. So you need technologies that are nuclear proliferation resistant as well as closing the nuclear fuel cycle. The Department of Energy's programs are working on both of those problems. The national labs have a position paper into the Secretary of Energy suggesting what we ought to do along those lines. Big research program is what it starts off with, but also very quickly cooperating with our partners around the world. So I think it has a role and it has a place. I think the technology options in front of it are very, very high. And that, in fact, it is not a given that it'll happen anytime soon. And we need public policy for encouraging, I think, responsible use of nuclear power, as well as the other things that I've talked about, which my laboratory is responsible for energy efficiency and renewable energy, so I naturally will focus on that.
May I have a quick follow-up?
Okay.
France generates 80% of its energy with nuclear power. Why can't we?
Well, there's a number of reasons. First of all, our nuclear power industry is bigger than France's. We only generate 20%, but we have a much bigger energy consumption than France does. 80% would be 4 or 5 times what France and we together already generate. I don't think there's a single answer that goes all the way to 80%. Personally, I do believe that there's an important role. I think we have a serious problem with aging reactors in this country. We're going to have to replenish the reactors we have today, let alone add to that. So I think we need a concerted effort in that area. I don't know that we can't get to 80%. On the other hand, I think there are other options that we have that are much more near-term and much more cost-effective and of lower regrets than I think what we have in terms of going fully one technology versus another. Other questions?
How hurricane resistant are those solar panels? How hurricane resistant are the solar panels?
Well, let's see. We have a number of tests that we put them all through. My wife asked me, so how much hail can we stand if we're going to put these panels on our roof? It's a valid question. I think probably as resistant as roofs can be. In fact, we have now tile solar panels that can actually just be the integral part of your roof. So as long as the roof lasts, then the solar panel will last. They are all guaranteed 25 years. So you have warranties for 25 years on all these technologies today. That's what I have on mine. And that's what I would expect would be a consumer requirement. So without answering your question specifically, I think if it's a Category 5, it's probably not very. But if it's something less than that, hopefully it'll last like the roof lasts. Yes, I'm sorry. I'm not paying attention to who's first or second. So just
thank you, sir. Regarding the wind technology, the power obviously is generated totally by the wind. The wind can be fickle. When you put in a study for wind driving the propeller blades, is there a study that considers that there may be a drop in wind at certain times of the year, which won't propel enough power energy to cover the energy that's normally required? There could be a drop-off or an estimated time when the wind is down and there's no energy being produced. How do you work that study out if there's going to be energy from a fickle source?
Okay, well, so the first answer to your question is we're running essentially I won't call it the experiment, but we're running a set of outcomes right now on utility grids. So XL, who is my utility, has roughly 2,400 megawatts of wind energy on the Colorado grid. They are managing that by the way the utilities work is they forecast a day ahead. And part of the difficulty that they have, and this is what they'll tell you, is that they can't forecast very accurately how much wind they're going to have tomorrow at this time. They can get close. They can get plus or minus, well, close is not, my close is not their close. My close is plus or minus 25%. That's where they are today. What they tell me is they need to get to plus or minus 5%. And we are actually working on climate modeling and a variety of things that relate to how can we forecast day ahead in the microclimate. Because every percent of, in XL's case, every percent of improvement in the uncertainty is $1 million to their bottom line. So they are really motivated to get that right. Now, it turns out that they have roughly 8% of their grid is wind. At night, when the wind's blowing and they don't have much load, they are up around 30 to 35% of their entire capacity is being supplied by wind. So they have to do some things differently than they originally contemplated. Now in Colorado, we've got an RPS that says 20% wind by the year 2020, or 20% renewables, which is going to be mostly wind by the year 2020. They're beginning to manage that. If you go to Denmark, they are at 45% wind today, year-round. It can be managed. It has to be done in a thoughtful manner, and it is in fact got bottom-line implications. And so you have to consider that. That's where those costs come in. And so it's not business as usual. You just can't slap the things in there and hope that they're going to work. You actually have to manage it. So we're running those, real-life experiences now, and we're learning from those experiences, and we'll get better at this. I'm confident we can get to 20, 25%, from wind without really compromising the electricity grid. Yes, you're right behind.
Talking about wind energy, I've heard problems related to noise, which is an environmental issue, as well as the sight, the visual, which is an environmental issue. We've also got environmental issues with regard to offshore exploring because of the beaches and the environmental issues of sight and so forth. What's your attitude or opinion in that regard for wind?
Yeah, I think the issues are real issues. Issues of aesthetics, the issues of whether or not they're putting the migratory paths of birds and also noise, I think are all real issues. I think those need to be approached responsibly. Like with any technology, and it doesn't matter what, you name the technology, fossil fuel, gas, whatever, if you don't look at all of those environmental impacts, if you don't look at land use, air use, water use, the things that really relate to how sustainable is our future energy economy, then I think you'll sub-optimize. Wind is not the answer for every location. Solar is not the answer for every location. Every location needs to have its own set of answers. What I tell the politicians in terms of public policy is I say, look, why don't you define what it is specifically that you want out of your future energy mix? It's got to be secure, and it's got to be safe. It's got to be affordable. It's got to have environmental, less environmental impact. It's got to have low water usage. I mean, the water usage in our fossil fuel industry today is horrendous. We can't continue to do that. And yet, it's never considered. We ask the questions about the renewable technology. We never ask the questions about the existing technologies. So address all of those attributes and variables and say, this is what we want out of a sustainable future energy economy, and then be totally technology agnostic and say, come one, come all. Let's do whatever it takes to get us to those attributes, and let's pay whatever it takes to get us to those outcomes. And that's how we should approach our policy, not technology by technology. I don't think it's a race between technologies. I think it's a race for sustainability, and I think that sustainability needs to be defined, and then we get to that outcome via market forces working, the way market forces work. I mean, the government's not going to do this. The private sector is going to do this. And we just got to give them the opportunity to do it so that we get the outcomes that we're looking for.
My question has to do with photovoltaics for an individual level. You have a lot of the mass generation of electricity. What about small homes in which you would not have the infrastructure problem of the large transmission lines and making it more affordable? How's the research going in that direction?
Well, I'm glad you asked that question, because I think it's kind of what I think is the value of distributed technologies. We helped design. In fact, we designed and Habitat for Humanity built a home in the Denver area, Wheat Ridge, in which we adhered to the criteria that Habitat for Humanity puts in place for the homes that they build for these needy families, and we didn't break the cost boundaries, and we built a small home that had essentially a really tight envelope so that it was very, very efficient, and it uses literally 30% of the energy that a normal home uses. And then we put some photovoltaic panels on the roof of it, 2 kilowatts to be exact, and we've monitored that home for the last 2 years. And I can tell you that home right now generates 25% more energy on an annual basis than it uses. That's a Habitat for Humanity home built to their standards. It can be done at a very, very small level, and I think for those of us that like the idea of getting off the grid, so to speak, it's doable. Now, every location is different. You need to tailor it around the conditions. That's a cold weather home, so you might have a different set of conditions for a home that's perhaps in a warmer, more humid climate. But the point is, the existence proofs are being done today. And I think it is a matter. In fact, Habitat is very, very pleased with what they're doing, and they've incorporated many of those design features into what we're doing going forward.
We have time for just a couple more questions.
Okay, and I'm sorry. Let me see. This gentleman over here.
Yes, thank you. I was wondering if your laboratory was doing any research on water as a renewable fuel source, like the water fuel cells.
We do a lot. Primarily, we try to avoid using water. I mean, obviously, what we're trying to do is water efficiency is really important. We have a number of what I would call revolutionary technologies that we're pursuing, some of which are direct conversion of solar to fuels, using water splitting as an intermediate without going through electrolysis to do some things by skipping some steps. All the stuff that relates to nanotechnologies, the laws of physics change at the very, very small level, small sizes and dimensions. And as a result, we're trying to harness some of those new things. So without specifically talking about water, because we don't have what I would call any kind of really robust technologies that really relate to water so much, but we do have direct conversion of solar to fuels and solar to electricity and photo conversion and a variety of things that I think are going to be game changers going forward. It was really interesting. I had the opportunity to host Larry Page a couple of weeks ago. Larry Page is the founder of Google. Many of you know that. And his interest was, like he says, I want the 10 smartest people in the whole world, and let's just go solve this problem and go do gigawatts at $1 watt. I guess you can do that if you're a billionaire. And what I told him, I said, you know, I really, you're inspiring to those of us that came to this laboratory 30 years ago, because we came to do that kind of stuff. We've not been allowed to do that. But for the vision and the resources to make that happen, I'm confident that the technologies and the innovation and creativity will be there. So I appreciate the question, because I think what it speaks to is that revolutionary, game-changing kind of opportunities that go with it. Yes, sir. Yeah, here.
You're inspiring to us.
Oh, thank you.
And of course, everybody wants to know what they can do to help. My real question, though, is considering the fact that you discussed the waste products of nuclear, and then I thought about the maintenance required for all of the other renewable energies, and the solar, the wind generators, and everything else. There must be something in the cost, of the life cycle cost, added for maintenance and disposal of the deteriorated or used up materials. So you want to address that?
Well, we do. What I'd like to fall back on is the fact that when we start looking at new technologies, especially those that are going to be disruptive technologies, I think we need to do that. Last slide, I didn't do it justice to spend time on it, but I think we need to do a full-up life cycle analysis. We've not really done that in many respects across many of the technologies. But what are those perhaps hidden or otherwise unknown kinds of implications of using these technologies when, in fact, you do scale them on a global level? What does that mean in terms of both water use, land use, value chain? What other byproducts do they disrupt or otherwise change behavior that give you unintended consequences regarding the outcomes that you're looking for? And I think we haven't really done that. We've really not analyzed our energy system as a system. We need to think about it holistically. We need to think about it in the context of global usage. And much of what we talk about today is showing U.S. leadership. The fact of the matter is, if we don't lead, the rest of the world is going to overwhelm anything we do. And it's China, India, Indonesia will have, in fact, China's already passed us in terms of carbon emissions. They will soon pass us in terms of every other metric there is. They're growing as dirty as we grew, without any. There's no restriction. We need to be thinking about, again, analyze that on a holistic basis, not just domestically but globally. And then how is it that we can help lead them to know to make wiser choices regarding our energy future? I mean, China's building a coal-fired power plant every 5 days, and they're not building the clean stuff. They're building the dirty stuff, and that's going to be there for 50 to 100 years. Now, if we can't export technology that is much more friendly to the environment, and for that matter, friendly to the economy, then we really have missed the opportunity that I think is really in front of us, because they're growing really rapidly. So it's really about leadership, and I'm back to informing our politicians. The U.S. needs to take a leadership role. We're the best at innovation and creativity. We can do that, and it can be in our self-interest as well as in their interest to do so. This shouldn't be a trade-off. This should be something that we do cooperatively and collaboratively. Because if we don't do it, other countries they're not going to wait for us. They're headed out and they're moving very rapidly. So this, I think, is an opportunity for us to regain leadership if we act now. If we don't act, I think we will be destined to whatever outcome others provide to us. So we'll take one more question, and then I think maybe.
Talking about the good technology and how this should be moving on, it also seems to be that there's something that's stopping it. What really is slowing this down? Is that the economics of the process, or is it the politicians who are saying we want it, but they're not allowing it to happen?
Well, now you're going to get me into a political conversation. And I probably will get in big trouble for this. But, I've tried to, I've been at this for 30 years, so I'm trying to figure out, so why are we talking today about the same stuff we were talking about 30 years ago? And a lot of it has to do with the fact we don't really have a very informed public. I think the consumers are a big part of what's going to happen I mean, we all elect our elected officials, and our elected officials act pretty much as though our representatives for the most part, representing what they believe our interests are. I think we really haven't had an honest dialogue around what the future energy mix ought to look like. And I don't think, I mean, it's kind of one of these things where when the price of oil is high, everybody's interested in energy, and when the price of oil is low, we're not. It's just that simple. I've got graphics to show that, when the price of oil is high, we get a lot of funding, and when the price of oil is low, we get low funding. It is, in fact, one of those very, very difficult political questions that has a lot to do with public perception. And a lot of it has to do with the fact that, today our homes are twice as big as they were 20 years ago. Our cars are no more efficient than they were 20 plus years ago. We haven't valued the things that we say we value. And we haven't been able to put a price on them, and our behavior is commensurate with kind of what our values are. So until we have an honest dialogue, I don't think we'll see a lot of change. That's why, there's got to be kind of some radical movement. God forbid that there's some sort of calamity or a huge crisis that we have to respond to. But unfortunately, that's kind of how this country works. We work when there's huge crisis. And somehow we got to get a crisis mentality without actually having to go through the crisis to get there. And that's the hard part. I think you probably wiser about that than I am, but it's frustrating because that's the part that we don't have. It's not. Now I'll say something really political. It's not really about taking any oil out of the Strategic Petroleum Reserve, and it's not really about taking a gas tax holiday on our gasoline. I mean, those two things are both. Campaigns have advocated those things. Those two things distract us from the real issue that's in front of us. Those are kind of, I'm going to help you right now and you don't have to do anything. We all have to do something. And it's not just about, put a sweater on, turn the thermostat down. It's not about that. I think there is plenty of opportunity here to use this as a tool of economic development and to do so in a way that's responsible as well as fuels the future and allows us to do what we do best, which is creativity, innovation, and business value creation. I think we can do all those things. But we need a different dialogue, a different discourse, and it can't be so partisan. It has got to be done on a bipartisan basis. And that's the hard part that I think as citizens, we have to demand that. Say, it's not about one side or the other side. It's about, we got to do this together. And that sounds kind of corny, but in fact, I think that's really where we're missing a big part of this. Hopefully after the election's over, we'll get back to thinking about it in that way. Thank you all for your attention. Thanks, Ken. Good. Thanks, Ken, and I just want to thank you for both warm welcome reception. Ken asked me to come here literally about a year ago, and due to schedule conflicts and a number of other things, it's been hard finding the time to put all this together, but I'm really glad this has finally happened, and I'm glad to be here with all of you. I get a chance to talk about renewable energy now. Gosh, I feel like I'm on the lecture circuit almost every week. And I start almost every talk with, it's a great time to be in the renewable energy business. It hasn't always been that way. I've been in this particular topical area pretty much my entire professional career. That's well over 30 years these days. I left Bell Labs when I was a young engineer to start the solar programs down at Sandia National Laboratories in Albuquerque, New Mexico, before SERI and now NREL ever existed, before DOE existed. It was back in the ERDA era. And so it's really quite refreshing to see how much things have changed, how, in fact, all that work that's been going on for literally 3 decades is finally coming to fruition. And I'll start with kind of the good news story, because I think the other part that I would like for you to take away this evening is that the challenge that we have in front of us in terms of our energy challenges for the country and, for that matter, for the world are horrendous. So the first question I will answer here in a moment. You know, I told the members of Congress it's real today. It's just not real in the U.S. It's real to the tune of $150 billion a year in terms of an industry, but it's not much in the U.S. And how much can we get is really answered by this particular graphic. This graphic is a projection. Again, EIA is the Energy Information Agency. IEA is the International Energy Agency. This is out of Paris. And then the Pew is the Pew Foundation. All of these various groups that project what the potential can be really have a bunch of assumptions embedded in what they assume. And what was interesting to me is that our policymakers look at these graphics and they say, well, gosh, if we're down here on this one, it's only 5% by the year 2040. You know, the conclusion one draws is why bother? You know, some of these others are a little bit more. What are the assumptions that are behind this? Well, they're over here in the legend, and the legend is that even under the most extreme conditions, we think that the price of a barrel of oil may get to $100 a barrel. So obviously, there's a problem with the assumptions, and it's very clear that what we don't know is we really have a hard time projecting where things are going to be. And I think what you'll find is that many of these folks, these are done by economists. They're done by econometric models, we call them, and they're a little bit like driving your car and projecting where you're going by looking in the rearview mirror. It's what has happened in the past, and if you just extrapolate what has happened in the past to the future, that's the projection you're going to get. That's kind of the way the models are geared, and that's essentially what you get. But it does not accommodate fully the market dislocations that occur when there are disruptions in oil and those kinds of things. It does not. The Energy Information Administration, it's the agency that's embedded within the Department of Energy that gives us projections about where our energy mix is today and where we will be decades from now. This is our mix today. You can see it's primarily fossil fuel, and it will remain that way for some time. Interesting enough, people will kind of be surprised by the fact that we've got 6% renewables today, and the projections are, even though the amount of energy required for the country is going to increase by 34%, that we only get to 10%. And I can tell you that 2 years ago, this same projection was that number would be 7%. So the good news is that they're at least acknowledging that renewables will be more than it is, more than it will be more than we thought it would be last year. But I will offer that it's still quite a bit less than what I think it will actually be. Now, if you just look at the electricity part and you ask where do we get our power generation from, and this is the map that gives you that. So it's primarily half coal, natural gas, nuclear is about 20%. Hydropower is about 7%, so all the total renewables is about 9.5%. This non-hydro renewables is 2.4%, and of the 2.4%, most of that, believe it or not, is biomass. People wouldn't expect that, but it's biomass power. Pulp and paper kinds of industries that use a lot of it. And here's wind. Wind is 27%. I'll talk more about that later. Geothermal is 15%. Solar is 1/2 of 1%, and that is of the 1/2 of 1% of this piece, which is only 2.4%, which is a little bitty minuscule piece. And I just wanted to reiterate that. Well, so I've been in this business a long time, as I mentioned, and the first question that I always get asked, and I got a chance to testify in front of Congress last year 5 different times. I got the same questions both times. First question was, when is this stuff going to be real? And the second question is, and how much can we actually get? They're daunting, they're incredibly acute, and I don't think the national dialogue really fully appreciates that. I think it's refreshing that we're having a national dialogue. I'm pleased that both campaigns in the presidential election are talking about renewable energy in particular, but clean energy and a new energy economy of the future. So I'm going to kind of run through my slides very, very quickly, hopefully to get some stimulation of maybe some questions that are really on your mind. I'm anxious to hear kind of how you view this topic, and I get a lot from your questions whenever I get a chance to talk to you about these things. So I'm going to go rather quickly. I'm going to say some things that many of you already know, and hopefully some new things that will come, be insights that will be of value to you as well. Our challenges are enormous. I said that earlier. Is it about security? Is it about economic productivity? Or is it about environment? Well, the fact is it's about all three, and we need to do those quite aggressively. There's mounting evidence. We all understand how our climate is changing in many respects. I think International Panel on Climate Change would suggest that that is human-induced, and there's lots of issues that relate to the effect that global warming is having. Probably the thing that gets to most of Americans is the price of gasoline. When you go to the pump and you all of a sudden see the price going through the roof, it really it starts to hit home. And this is really where the dialogue has begun. In recent years, it's really about technology, rather about energy security than it is about anything else. And so let's examine that for a moment, and then I'll come back to what renewable energy is and the value and the role of R&D that goes along with it. This is taken into account, obviously, the volatility of the price of oil and innovation in the R&D community. So that is where I think there is great opportunity, and it really then helps me answer the question that I get from the Congress, which is how much can we aspire to in terms of renewable energy and energy efficiency? And I take that question and I turn it around and I ask it back to the member of Congress and I say, how much would you like? Because it is not a matter of technical potential. It is a matter of investment and commitment to make these outcomes that you want to have happen. The good news is I had a chance to host the president a couple of years ago back at the laboratory, and he came and we had a nice discussion around a variety of topics. But what was interesting to me was that there was no lack of will for suggesting that there can be a large fraction of our energy mix in the future from renewable energy. And it is a matter of investment and technical will. So in the national program today, here is what you see in terms of our aspirations. And I'll call these aspirational goals, not because we can't get there, but because it takes a lot of things in order for us to get there. And I'll mention that here in a minute. A couple of months ago, we unveiled a thing called the 20% electricity vision. This is a report that we co-authored at the National Renewable Energy Laboratory with the Department of Energy and 50 other groups. And essentially, we developed the roadmap by which you get to 20% of our electricity from wind technology by the year 2030. Now, this happens to be the report that if you're watching any of the news programs these days, you'll see T. Boone Pickens up talking about renewable energy and talking about wind. He holds this report up and says, now he wants to do this in 10 years, which I find really aggressive, but T. Boone has a lot of experience in the marketplace. I mean, I certainly do value how he approaches things.